Okay, it is me, Lord of the Weird, Squiggly, Red Lines. Let's figure out what's going on with that, shall we? Alright, so I left myself a little note from last time. Good job, past me. And I have to fix sprite index because it's doing double duty, which is wrong. So, oh, too cookie. My cat is also here. He was sitting on my lap when I started the stream. I also wanted to say a big thank you to 8 Little Bits for the Twitch Prime subscription. As some of you may have noticed, I somehow became a Twitch affiliate, and that's the first person other than Diana to subscribe, so I appreciate that. Pretty sure I'll never see any money from it, but maybe, who knows. Okay, so what is going on here? It should explode eventually, right? I think that's how this works. Sort of forget what's going on exactly, because I thought that it would blow up, but maybe it's not doing that. This is where I was dumping out the huge thing for no good reason. Did I just like turn off sprites entirely? No, that's still running. Alright, let's see, where are we? Hi, Pixel. What is no? Wow, that's extremely slow. Again, I must be doing something extremely stupid when it comes to rendering. That's why it's so slow. Let's run the donkey version. That explains why it wasn't exploding, just wasn't making it that far. Yep. So I have to figure that out. But first, sprites. Okay. Sprite index. So sprite index is used for the reading of sprites, which is fine. But I think it's also being used to write to secondary OAM, which is not what it's supposed to do. I think I also have like a sprite count thing, and that's probably what's supposed to be being called there. Except that the offset thing doesn't make any sense. That's right, I remember now. Okay, so right, so we've got sprite count, and then we've got write OAM. Write OAM is getting pushed from all of these. And then we're trying to calculate the cycle, but it doesn't actually work that way. So let's just add a new field to the TPU struct, even though maybe we don't need that, but who cares? Sprite count, sprite index, sprite offset, U8. Sprite index, we're going to go to the bottom so that we can initialize sprite offset to 0. And then whenever we rewrite to secondary OAM, we're going to go in here and we're going to write to CPU.sprite offset. Oops. And then we're going to do sprite offset plus equal 1. And then here, sprite offset, CPU.sprite offset plus equal 1. If sprite offset equals 4, increment that, set this back to 0. And hopefully that'll work. We'll just do this. And go. Nope. Forgot to as you size it. Oh hey, you still exploded. Writing to offset in secondary OAM sprite 7. I mean, that seems right to me. The length is 32, but the index is 33 at 628. In fetch sprite low, this doesn't feel like a good thing either. I'm probably double using something here too. Hi Lila. Shouldn't you be asleep? Do you regularly stay up till 4 a.m.? Currently, yes. Do you like work nights? What's the deal? I bet this is supposed to be sprite index. Do we increment it in? Yeah, because we use sprite index here. And then, do we increment sprite index in here somewhere? Yes, we do. Yeah, so that's what's up. I have the freedom to work whenever I feel like it. Must be nice. Although I guess I kind of do too. Up to a point. Hey, address 4016 not implemented. That's a new problem. Hi, kitty. Again. I don't think we have a 4016, do we? What's in that position in the memory map? There we go. APU registers. And I/O registers. Okay, so if it's APU, we just don't need to do anything, because who cares? But it looks like it's not, so is it an I/O register? Joystick data and strobe. Okay, so I can just ignore that too for now. We want input. My little emulator's growing up. Fix that eventually. Okay. So that exploded in CPU. Get byte, probably. Right? Where was that? 2144. So if we're in that there I/O space, which is from 4000 to 18, else if adder is greater than or equal to 4000 and is less than 4018, line write to unimplemented address adder. Cat, you make it so hard to type by slipping on my arm like that, even though it's adorable. Missing lifetime. Oh yeah, because I didn't close the bracket. Doodly-doo. Oh yeah, use of possibly uninitialized value again. Just return. And then we exploded again. What happened? Assertion failed, address less than 2000. On line 2072. So that's probably polling. Yep. Read from unimplemented address adder :X. Go. We'll probably explode somewhere else, but yeah, there we go. Index out of bounds again. How about that? In the NROM mapper, the length is 16, but the index is 31. Okay. That's line 91. Okay, so we're trying to write to the palette RAM, but at an invalid index because the length is only 16. Is that even right? Where's my PPU memory map? Doo-doo-doo. There we go. Okay, so we're writing to the palette RAM, which has a size of 20. I don't know why I thought that this was 16. It's obviously 32. So that's actually fine. I'm just a goofball. Go! Oop. 32. 32. Go! Okay, and then we blew up at 88, which is in set byte PPU. What is the address that you tried to write to? I thought the pattern tables were supposed to be in ROM. Okay. Writing C5 to address C5, C5. Well, that doesn't seem right. This was called from where? Set register at PPRS 845. So that's got to be a direct write to PPU data, right? PPU registers 2007 is PPU data, right? So that makes sense. PPU reading and writing shares the same internal address register that rendering uses. Okay. We're gonna go ahead and print this junk a couple of times. Write to PPU adder, new latch is whatever. Write to PPU data, new latch is whatever. And we'll just kind of see what's happening. Kitty. Okay, that looks like a direct write. New latch value C57E. I wonder how that would have happened. It looks like we're kind of just going through. Right, so we write it at 3FF0, which is the palette RAM. So we're trying to fill in the palette RAM, I guess. Oh, that's interesting. They wrote 3F to PPU address twice. Isn't there a thing about it being supposed to ignore a write or something? No, I guess not. So, I mean, that just doesn't seem right, that it's writing 3F twice like that. Are any of these I/O registers actually relevant? I suppose I should look at them, huh? That was over here. Oops. APU registers shouldn't really matter, I guess, because it's an APU. Should be fine. The rest of this stuff, OAMDMA. Yeah, none of this looks relevant. So what's going on here exactly, I wonder? Well, first of all, I should stop printing out all these guys. Should just turn those off because they're getting in the way. And then I probably am going to want to see the execution state, which I've got that right here. So we'll just do that. And that should hopefully tell us something. Kaboom! All right. Like, it's pretty obvious that what's supposed to be happening is that it's filling the palette RAM, but it's obviously not doing that because it tries to set 3F00, but it ends up setting 3FFF, or 3F3F. So, why would you think your accumulator is 3F, but then it doesn't change, and maybe it's supposed to be changing? I don't know. I need to print the opcodes that are decoded. Did you check your function where you fill PPU address? Yeah, I did. It's right here. All right. I mean, I guess I can just run it again. I should probably just make it explode then. Kaboom. All right. Yeah. So it's definitely written to twice with 3F as the value, which is what makes me suspect a CPU bug. I'm wondering if the A is supposed to change and I've screwed up some function that's supposed to do something. Right? See, this looks like a reasonable value, but then this is obviously wrong. So C8, B1, 8D are the functions. C1 is a compare. Oops, no, it's C8, C8. Just read it. Increment Y register, which does happen. B1, load accumulator, indirect Y. Store accumulator, absolute. Okay, so whatever is in that address, but I passed nest test. Well, yeah. That was a while ago. Maybe I should run that again. See if I broke it at some point. Invalid instruction A3, which I'm pretty sure is the, yeah, that's an maybe your latch clear in the if statement starts with the wrong value. I don't think so. Like, I don't think that's what's going on because it shows, when I run it, it shows, setting high latch first and then setting low latch, which is what it should be. So, I mean, it's obviously writing 3F twice because this is a write absolute and the accumulator has a value of 3F. So the accumulator is supposed to be loading something from memory and is not loading what one might expect it to load. Like, that's what must be happening. So, what is D0? Branch not equal. Do check nest test again to make sure. Well, I know I did have one issue, which nest test did not complain about, but I had a problem where the flags are getting set on instructions that shouldn't be setting the flags. I can't remember which ones, though. Okay. How does nest test die again? It's if you write to 2 or 3, right? The BNE right before that would make a CPU bug likely then. Yeah. You would think that nest test would get that kind of thing, but I don't think that it does. To be fair, lots of people don't write negative tests. Yeah, I don't think it covers everything. How to work it good. How do you know if it explodes? Run automation. Formal test in secret. Shove the results of the test into locations 2 and 3. Right, so what we had was something which basically asserted that those elements were empty. Address if address is equal to 2 or address is equal to 3, assert value is not or is equal to 0, print line write to address with value, adder value. Oh, that was the donkey one. My bad. Nest test. Go. Yeah, I mean, nest test runs fine up until it hits an invalid instruction, as far as I can tell. Maybe I should just panic here. Yeah, so I think the best thing to do, probably... Did you compare to the golden log? Yeah, I did. But, like I said, I noticed that my flags were sometimes wrong. I just forget where. So, I'm just going to walk backwards from this to see what instruction was right before it and fix that, and then it will probably tell me all the other ones that are messed up. So, alright, so D0 is branch if not equal. And it's immediately after a B1, which is a load accumulator, which does set the 0 flag. I'm pretty sure I have that right. It's load A, indirect Y. It's read 2 that sets the flags. Right, so we have update flag loaded 0. So it's probably not that exactly. But yeah, so this is basically the thing, right? I have this read to, and then I'm updating the flags, even if the register that's read to is not the accumulator, which it sometimes should work that way, but other times it shouldn't, I think is basically the problem. Like if I read out something that's going to be an address flag thingy, then it becomes problematic. So I'm pretty sure that's what's going on. Add does accumulator. Or and. Right, okay. Shift left. The branches probably don't. Right, because fetch to, I think, does not update. Yeah, it doesn't. Although, again, maybe it's supposed to in some cases. I forget. All right, let's just... yeah, that's what we're going to do. We're just going to run nest test and start at the beginning and compare to the golden log and see where we screw up. Because I remember it being relatively early. So... log. Okay. Zoom this in a little bit so that both you and I can read it better. Okay. A2, 86. Oh, I'm not printing P. I need to print P or I'll never know. Fetch and decode. I hope you have any diff tools. Not really, no, but I don't think it's going to be. I mean, I guess I could make it look like this pretty easily. There's like a bunch of weird shit that I don't really understand in this format. Oh yeah, you gotta actually pass the thing in, dummy. Oh, God damn it. There we go. Go. Alright, so here we are. Okay, well, for starters, P started at 34. So that's wrong. Remind me what you're supposed to be. CPU register power up state and then registers. Because I thought it was supposed to power up to 34. The golden log differs from this in the irrelevant bits 5 and 4. Okay. So let's mask off bits 5 and 4 then, I guess. 0x, 5 and 4 would mean C and F. Okay, well that's just a 4 now, which is also not ideal. What the heck, man? Alright, oops. Status register. Shouldn't you have some sort of any kind of information about what the status register is actually supposed to be? Okay, you're insane. What makes you say that? XX diop diop? No, that's not it. .txt. There's like a... This one. This is what I was looking for. The title, 2-week NES Emulator Challenge. Yeah, this is the second to last day. So we're not quite there, unfortunately, although we will be continuing to try right down to the wire. Okay, so we got negative, overflow, always 1. And then we got break, decimal. Okay. So basically, I was setting break, and they are not setting break. And it's supposed to be set. Why are there Dendy instructions on the NESDev wiki? I don't know. I'm not even sure what a Dendy is. Some sort of knockoff. Alright, so let's just or it with 20, since that bit's irrelevant. And then we'll just run it. Okay, so that should hopefully let us see things that actually matter. I'm going to follow and watch later. Awesome, thank you. This will also be on my YouTube channel, which just I'm a Waggle on YouTube, if you'd rather watch there. Okay, so we got 24, 24, 26, 26, 27 for 3 lines, 26, 27, 26, blah, blah, blah. A4, that seems interesting. but it is in fact correct. Oh, thanks, Diana. Diana dropped the link to the YouTube channel in chat if anyone is prefers that method of watching. A4, E4, 60, 67, 60. I probably should turn this into something a little more difficult, but I don't really have like nice decodes like this, so it's going to be challenging. Although I guess I could just take it, dump this junk, and keep this also. That's probably the best thing to do if I was actually going to do it, is to strip out all of the extra stuff and then just print this part and the PC part. Yeah, I can regex the mnemonics out. Yep. Because that's what I wanted to do today, is write regular expressions. I just looked, I deleted mine, I did the same. I mean, if you wanted to upload a doctored log that contained all of those changes so that I don't have to do it, that would be super cool. Just saying. Oops. Actually, it may not be that difficult to do. What? Okay, there we go. All right, I might just be able to do this, right? Okay, well that was easy enough. And then I'm just going to put PC at the front of this. Oops, that's not right. Yeah, man, Vim is the best. Okay. And then I will go in here and I will modify this to basically just remove the spaces and the commas. And the sharps, I guess. And it probably is going to want to be a 2 also, but we'll see. And then get rid of any other print lines. Okay, how about in the PPU? Okay, I really need to do like real ass logging so that I can filter stuff like that more effectively. Oh no, I'm printing my PC one after. All right, let's go ahead and fix that. Oh, wrong document. Okay, so the problem is that I am incrementing my CPU in the fetch byte opcode, so we got to do the print here. And then that looks correct, except that it's not always 2, and it doesn't have the stack pointer. So I need to add that. SP ::X CPU view.regs.s, and then we want these all to be x2s. Can't remember if it's just x2 or if it's 0x2, but we'll find out. Whoop. Yeah, invalid format string. It might even be 2x. Let me just double check how that's supposed to work. So it's 02x probably is what we want. Sweet. What? Huh. Those look like those should match. I don't understand what you're complaining about, diff. Row 1. Huh? I don't know how to read diff, unfortunately. Okay. Report only when files differ. So it would be Q, I guess. May I propose to move your face cam to the top right? Sure. There you go. How's that? Okay. I think we want to just ignore all white space probably, which is a -W. And let's give ourselves 25 lines, I guess. 50. Okay, so D1FA is apparently where we run into this issue. So let's go and look at the log and look for D1FA. Branch equal. And the distinction that we find is that X is wrong. That's odd. So I have a problem with load X, I guess. So that's A6, which is load X immediate. All right. No, load X 0 page. Okay. Yep, A6. Oh, well, okay. My load X loads to Y. That's a problem. Yay, bug fix. I seriously doubt that it's the problem. Well, it could be. I guess it could easily be, now that I think about it. Okay. D445. Load accumulator. 0 page, I think. Which is probably also loading Y. Oh, no, that looks right. A5. Okay, so what's the distinction here? Oh, now we have a flags problem. Okay, which does make sense. So load A is almost certainly supposed to change flags, right? I need to move that reference around so that it's closer to what I'm looking at here. There we go. Go. Okay. A5. Load A. Oh, it's probably what comes before that then, right? Because that's not... Okay, so right before the load A is arithmetic shift left. Yeah. Which one? ASL 06 0 page. So ASL ZPG. Fetch, read to, write, shul in mem. So is shul in mem the problem? I doubt it. Oh, would you look at that? It is. Testing the carry based on the rules for shift right. Gotta say, this does make you wonder what the point of NES test is. It's not catching any of these bugs. Alright. D573. Load Y. Absolute, maybe? Is that what AC is? Match case, dang it. Yeah, absolute. So, LDY abs. Fetch 2, read 2, fetch and decode. Fetch 2 doesn't set flags. So what's the problem? The differences are in the value of Y, 4623. Although it's probably the... Right? 573 means that it's this load Y absolute. And it's supposed to load 46, I guess. But it is instead loading 23, which is what is in X. There's got to be a way to tell diff to dump some stuff before, right? Output some context. I want one that's like suppress common lines, expand tabs and stuff. I really feel like there ought to be a way to do this. You can do it with head. Why can't you do it with diff? Alright, whatever. I mean, I guess I can just look. So that's D573. Okay, so it is whatever's happening at D570, which is this load Y. But it could easily be that the memory that it's supposed to be loading from was stored wrong, which is this store Y at D567. But they did match up to that point. So either we're addressing the wrong address or we're not storing correctly. So let's look at STY. What is that? STY absolute, I guess. Is storing register X. Cool. I should probably just go through and make sure that all the functions actually write to the register they claim to write to. D942. The difference is the status. Hooray! D942 is doing a load accumulator indirect Y, apparently. And the status is supposed to change to E5 for like 1 cycle, but it doesn't do that. That's interesting. And then the compare happens and it becomes 67. Okay, so load A, indirect Y. Fetch 2, read an increment, fetch indirect, read 2. So does fetch indirect set flags? No. Does read and increment set flags? No. Does read 2 set flags? Yes, it does. Z and N. What flags are supposed to be modified by load Y? Z and N. Okay. What is E5 versus, what was the other one? E5 and 67, right? So the difference between E5 and 67 is that bit 8 is set and bit 2 is clear. Bit 2 is the 0 flag, and bit 8 is the negative flag. Those are both the correct flags to be screwing with. So, what's happening here? The Y is correct, right? And it's 34. Or no, it's the A, it's the accumulator. So we're loading a 0 instead of an A3, which that makes sense. So why are we doing that? Presumably because we stored wrong. The previous store, which is load Y34, 97. I don't know. What are we even reading at? All right, well, we do a couple of store accumulators, and that's all we've done since the last thing. So it should either be load A immediate or store accumulator 0 page, I think that is. Let's just double check that. 85. Oh, you're wrong. 85. Store accumulator 0 page. Yeah. So I mean, immediate STA is kind of doesn't really make sense. It's 0 page, but yeah. Bit could be wrong. So what's happening is that 0 is getting loaded into A. Oh, and then it stays wrong for a while, right? So it's wrong for these, and then here it loads EB, but then it becomes right again on 46 right here. And then it gets screwy again. So there's a bunch of junk in here that's being wrong. So maybe my load indexed Y is just not right. LDA indirect Y is 81, which is correct. I don't think I have any other 0x81s. Oh, hey, look at that. Oh, no, it's B1. Sorry, I just misread the B. Okay. There's no other indirect y. Oh, well, I'm not offsetting it by y at all, so that probably doesn't help. And these are wrong also, probably, considering y is never involved in any of them. So that's cool. I really feel like that should have been caught by NES test. Maybe I'm just diagnosing wrong or something. But anyway. Makes you wonder how NES test finished. Yeah, exactly, right? Indirect indexed. Its instruction contains the 0-page location of the least significant byte. The Y register is dynamically added to this value to generate the actual target address. I think probably all I need to do is change fetch to fetch an index with 0-page wraparound. So how does fetch and index work? Hello, cat. I am surrounded by cats today. They're in both chairs. One of them's on my lap, one of them's on that chair over there. If it's greater than, so it's not doing the wraparound. And this is fetch index no wrap, which I think is what I actually want. Do I ever use that? Fetch index no wrap. Oh, it's used in 0-page X, I guess. Anyway, indirect Y. Let's do it. We should be able to just fix fetch index no wrap ABL Y. Alright, we'll fix just this one because it's the first problem. So if this changes, it was D942. Troubling. This suggests it's like extra broken now. All I did was break it worse. Woohoo! Maybe I should fix all of them, I guess. Or fix, since I haven't actually proven that they're improved by the thing that I'm doing. Why am I doing read and increment? That doesn't seem right either. Actually, I should just redo this entirely, right? That's what I should do. Okay. Let's go over here. Please keep moving. Thank you. Okay. We want indirect indexed. Okay, so fetch opcode is fine. Fetch pointer address increment PC. Fetch effective address low. Fetch effective address high. Add Y to low byte of effective address. Okay, so this isn't actually what the problem was. Okay, so does that match what this has to say? 0 page of the least significant byte dynamically added to this value. Okay, yeah, so that's the problem. All right, so I was right actually with the fetch. And then we do read and increment. This was wildly incorrect. What we want to do is we want to do fetch, and then we do read and increment, which does nothing of the kind, as far as I can tell. What are you supposed to be incrementing, buddy? Effective address is always fetched from the 0 page. Okay. So this should be read inc no wrap for one thing. And then fetch indirect? That doesn't seem right either. So you get the byte, you set that, you get the temporary address. Oh, here's where you add Y. Why did I do this in line? That was dumb. Okay, so that's when that happens. Add Y to low byte. And then if we do his page cross, then this is to fix the high byte stuff. So that ought to be fine. And then read from the effective address into A. So maybe this increment no wrap was the problem. Expected 1 parameter. And I guess, yeah, that should be fine. Okay, so we made it to where we expected to make it to again, which is good. Looks like we're still wrong on D942, though. Because we're loading 0. If you're doing any other indirect Ys, we're doing one here. The first 10 minutes really nicely explain what each addressing mode does. Fetch indirect. which for some reason is not doing, just doing fetch and index with register Y. I don't really know why. It looks like it would be the same. What's the difference? Fetch indirect, fetch and index. The only difference is that it's using the PC instead of the address bus, which I guess is fine. Whatever. I'm gonna fetching from address plus y cpu.get address plus cpu.regs.y. And then we're just going to panic at the end of this so we can see what's going on. And we're going to run this without dumping the log. Go, 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 go. Oop. Fetching from address 8a plus y equals 0. Well, that doesn't seem right, does it? Okay, so what Lila is saying in the chat is to look at this. Actually, let me tear it off this screen so I can still see chat. So basically it looks like, yeah, so load A20Y is that you load this, right? This is DEF20. So you load 20, 21. You get AC20, and then you add whatever was in Y, which is 4, I guess. Oh, well, that doesn't seem right, does it? Oh, no, because it's AC30, right? This is 2B, C, D, E, F, 30. Right, so you would expect this to go to A0, right? Am I missing something? Does he eventually say, no, this diagram is a lie? I don't understand this. Because you fetch AC30. I know, somewhere is a single mistake that he talks about. Oh, is it this? Because that doesn't make sense. Because that is 30. There's no adding of Y happening. Anyway, I mean, this matches what I want to do, right? You fetch the address, you add Y to it. So, oh, okay. I'm printing that at the wrong time. It was not a valid description of what was happening. Fetching from address 300 plus y equals 0 sounds a lot more reasonable. Yep, address 300. Okay. Let's not panic on that then. If CPU.get AB is not equal to 300, then panic. And that way we'll get it at the next time. Kaboom. Okay, so that's correct. Fetching from address FF plus y equals 34 is probably not right. Or is it? No, it is. And so then plus y equals 34 is supposed to give us am I just not fetching anything, actually? That's what's happening. Oh, no, I guess that's fine. Final address. The 0-page wraparound is broken for some reason. Final address is FF. That doesn't seem right at all. That says at 33, which makes way more sense. How did that occur? So, temp address is right here. Does end up being greater than oh, I'm only correcting the address, the high address, but I'm never assigning the address back to ABL. I'm never doing this step. That's what's going on. So this only works if y is 0. Final address 33. Hooray! All right, let's get rid of this junk and keep going. I think there's still a bunch of problems, though, with all of my indirect y's. Indirect y. Because they need to do read increment no wrap instead of read in increment. At least I think so, anyway. I maybe should not be changing everything until I've absolutely confirmed that, but, you know, whatever. Live fast, die young. Okay. Let's run this again. Open these up. Delete that. Diff it. PC 300. I guess we do go there. Okay, cool. Load A immediate appears to be the problem. Or no, actually, it's more likely to be this jump. Although, why would the jump be wrong? Oh, okay, that's not a real problem. I know what's going on there. This needs to be 0.4x. It's about leading zeros. Diff it. Okay, there we go. DE B4. Load X, indirect Y. Or no, load x absolute y. Or load x 0 page y, actually. There we go. Okay. Which the difference here is both x and y are wrong, so I'm probably loading into y or something. LDX is EPG y. Or LDX absolute y? LDX. Immediate, abs x, ZPG, ZPGX. Wait a minute. That doesn't really make sense, does it? What? What is address B6? Okay, so it is supposed to be Y, and I just wrote it as X for some reason. And then probably BE is the same. Yep. Load X, absolute X is stupid. Load X, ZPG X is equally stupid. Missing a mode? I mean, no, not, well, yes, but also I invented another mode which doesn't make any sense, which is indexing X by X. Oops. That wasn't what I meant to do. Diff it. Okay, at least this one is loading to X. Load X 0 page was loading to Y. So that's why that was still wrong. I really should figure out how to make it not put all that junk at the beginning so I don't have to do that every time. Okay, DF16. The difference is that A is wrong and also P is wrong. DF16 is load A absolute, I guess. That's what that is, A5. Load A 0 page. A5. That seems right to me. I guess it could be a store that's wrong. DF16 is load A from 7F, which is this store X, absolute Y. So that could easily be wrong. Oh, I just straight up don't have that? What? That's 96. Okay. Yeah, again, same problem. STX ZPGX is not a thing. Index it by Y. DEFE, is that the address of the, yeah. C64. Oh, these are multi-byte no-ops, so who cares? Okay, cool. So we fixed all our bugs. There are no more bugs. I don't want to hear anything else about bugs. They don't exist. Alrighty then. So what was I running before? The donkey test, I guess? Donkey. That's a different problem. All the bugs have been squished. Yeah, it's not exploding in the same spot anymore. So, okay. PPU 393. Ugh. Braces suck. Don't get braces. Just have good teeth. That's my suggestion to you. Okay, so why did that happen, friendo? Let's turn on sprite logging real quick and turn off CPU logging. As great as it was. Dang, I've only been at this for like a little more than an hour. Feels like a lot longer for some reason. In a good way. Doodly-doo-doo-doo-doo. So the test sprite, I should probably is that what that was? No, 393. All right, so here's what we're gonna do. We're gonna say if PPU.sprite index is greater than 255, print line sprite index is whatever it is, sprite count is whatever it is, sprite offset is whatever it is. And also, well, I guess it'll just explode anyway, so who cares? Shablam, okay. Sprite index 256, sprite count 3, sprite offset 0. That seems a bit odd. Set to 0. It is modified here. Although I guess I changed it to be a 16, so that's wrong. Sprite index plus 3. If sprite index is greater than 255, panic. Why is this not a U8? I ask you. Because it would seem that that's the problem. Uh-oh, tried to access non-existent RAM. That doesn't seem good. Address less than 8,000. Just ignore if it tries to write to RAM. F36. I mean, I could do that, but it feels like it shouldn't be trying to write to RAM that doesn't exist, is the thing. So I'm worried that I've screwed it up somehow. I want to do one thing real quick. So we're just going to do we're going to stop doing this because it's not very helpful. And then I'm going to run this. We know it's going to fail. Going to see what cycle it fails on. Boom. Okay, and then we're going to redo the change to U8 and run it again. I'm sure some devs relied on memory just not being accessible instead of writing fancy ranges. I mean, I agree with you that that probably did happen a lot, but I'm also concerned that, like how would you tell the difference? You know what I mean? So I'm gonna turn on CPU logging one time and just take a look and see if there's anything that's like obviously stupid. Yeah, sure, hard to know and annoying to assume such things. Yep. Accessing invalid address. Oh, see, this is why you can't do that. This is the program counter. It's trying to fetch from RAM that doesn't exist because the program counter has gone bananas. Operation 40, which is return from interrupt. Alright, so we're returning from interrupt incorrectly. If you look at RTI, we pull P, we pull PCL, we pull PCH. And then if we look at the only interrupt we have is NMI. So we push PCH, PCL, P. So that should be right. Did I change the stack operations on NMI and RTI? Not totally sure what you mean by that. I think I changed the order in NMI. I don't think so, right? Because so first we push PCH high, then we push PCH low, then we push status, then we pull status, then we pull PC low, then we pull PC high. That seems like that should work. Is the stack pointer being incremented, decremented in the right order? Probably that was going to be my guess also. So if we look at push, and we look at pull, or not V-split, regular split, and we look at NMI, so for push, we are writing and then subtracting, which seems right because you're pointing at the open byte, you write to it, and you subtract, now you're pointing at an open byte again. And then for pull, we're adding and then reading, which seems to match. And the thing that is being done, oh, also all the stack pointers matched NES test, so I assume it was correct. And if you look at what I'm doing here for NMI, that does seem to match, right? So we get the value, which we already have the value, and we call set byte S plus 100 to the value, which is this. That seems right to me. Even though it super does look like I'm popping the even though it super does look like I'm popping the status flags into the program counter somehow. I should get rid of this writing to address thing also. Yeah, and it's not like this is the first time I've executed an NMI either. But for some reason it comes out screwy in this case. Right? Like we've done a bunch of these. It's almost like we're manipulating the stack at that time. Yeah. What's your initial SP value? Like FD or something? I forget. This is the wrong file. That's why I can't find it. FD, yeah. Which I believe to be correct, according to this. Yeah. Okay. So it looks like I'm executing pull or push at the same time, right? So if we do if UOP or match UOP microphone push print line pushing microphone pull print line pulling. Otherwise, do nothing. Do-do-do. Wow, that's a lot of pushing. There's no way that matches up. 1, 2, 3, 4, 1, 2, a lot, a lot, a lot, a lot. No wonder it's not working. Well, I guess that's not necessarily true. It sure looks like it's screwy, but it could be manipulating it some other way. I don't really know. Oh boy, oh boy. Is my stack wrapping around? What's happening here? It's annoying. Self.regs.s. It does look like the stack wraps around at some point. Several times even. Oof. What's going on here? So the high byte is not getting popped into the PC. Instead, we're getting the low byte and the status register, which, if we look at RTI, it just looks like we're off by 1. So it's probably some sort of timing thing, although I'm sort of surprised to hit, because this must be a sub-instruction timing thing, right? So if it was going to be one. So that seems a bit odd. Fetch opcode, increment PC. Read next instruction byte and throw it away. Push register on stack and decrement S. Fetch opcode, fetch next instruction byte, increment S, pull register from stack. So we're supposed to push and decrement, and then we're supposed to increment and pull. So this says 4 cycles, and so does that, which does make sense. Push is only 3, according to this thing, as opposed to this one. Oh no, that also says it's only 3. So PHP, PLA, etc. No op, push, fetch, and decode. It shouldn't be wrapping. I just read that it's rather rare that the stack is even used to its full size in NES code. Yeah, I'm surprised that that is happening. It doesn't really make sense to me either. So I don't know what's going on there. Am I manipulating the stack ever? CPU.regs.s. Wrapping sub, wrapping add. Wrapping add. Is NMI the only thing pushing to the stack? Let's find out. I mean, there are other opcodes that can. Let's see if we ever call push directly. Yep, something is pushing to the stack. The only things it could be, at least in theory, are PHP and PLP and PHA and PLA. I wonder if I'm using S when I should be using P somewhere. That would explain a lot. It could, yeah. Stack to X move. X to stack move. Could be doing it, I guess. Okay, so we're calling X to stack at some point, which is sort of surprising. I don't know why that's surprising, but it surprises me. Just doesn't seem like that useful of an instruction, frankly. Right. TXS. Writing to S from X. CPU.regs.s. Oops, too far. Writing 255 to S from X. That's sort of interesting. But I guess it's not a big deal, and it doesn't really happen very often. So it's got to be a push. It's getting called. Oof. TXS is only X to SP, right? Yeah. Not to the stack itself. No, but it moves the stack pointer, so that's what I'm looking at currently, is if the stack pointer is wrong. Doodle-doo. I should probably make that a X, huh? Well, that's doesn't seem right, does it? How do we, in two calls to push? Oh, well, I guess the NMIs happened. That's why. What? Oh. It's so weird that it just like goes bananas at this last thing. It's like, hey, we're gonna do all of the stack manipulation now. We've never done any of it before, hardly. Notice that we're never RTIing from these NMIs. That's troubling. That seems like something we should be doing, don't you think? Because RTI would activate those pulls. So yeah, RTI should be happening, obviously. But you can't mask NMIs. Is there like a nested NMI masking? I don't remember reading anything about that. No, yeah, I didn't think so. So why aren't we getting out of the NMI? Are we jumping to the wrong handler location? Oh, you know what? Push front. Microphone, fetch, and decode. We aren't actually jumping. That's probably important, huh? Alright, we still exploded. So we have not resolved all of our problems. But let's see. Actually, it seems like we haven't really resolved any of our problems, have we? Oh, cat, come on. Off the keyboard. Fluffy cat. That looks way smoother. Does it? Because it still is just executing over and over again with no RTIs. I don't know why. It seems like we ought to be, but let's double check. Doesn't look like it somehow. Although I guess we didn't really check what the NMI handler was, did we? Well, the PC is always the same after the NMI occurs, which is C8-5F. We didn't know for sure. NMI vector at self.getPC. Okay, so we are jumping to what we think is the NMI vector, but then we never get anything else. Are we just getting an NMI every time? Are we getting an NMI every cycle? I bet that's what's happening. Do I count the 10 in the INES header? Yes, I do. I bet what's happening is that the PPU is returning an NMI every cycle. Don't remember how that works. NMI. So 2 1-bit registers inside the PPU control generation. Start of vertical blanking, set NMI occurred in PPU to true. End of vertical blanking sometime in pre-render scan line, set NMI occurred to false. Read PPU status, change that, write to PPU control, set NMI output to bit 7. So, oh. I'm not edge detecting NMI. I'm just firing an NMI the whole time it's low. I'm level detecting it. That's why it's not working, because we're getting an NMI every goddamn cycle. Struct CPU NMI. Cool. Self.NMI. Or no. If NMI and not self.NMI. Self.NMI equals true. Do this junk. Else if not NMI and self.NMI. Actually, you know what? I guess self.NMI just equals NMI every time, regardless. But we needed a latch. Invalid instruction 0. That's cool. Okay. That looks more correct, because we're actually executing stuff. But only one NMI happens, apparently. I wish I had a better way to do RTI. To like print when I hit an RTI. I mean, I guess I could just do it this way. Oh, geez, everybody be texting me. Never fails. All right. NMI. RTI. Okay, so RTI does happen eventually. That's good. And NMI does as well. And after RTI, things continue to be like relatively sane, which is great. We should probably actually print this so that we can just check to make sure that we get the right PC back. Hi everyone, by the way. I realize I haven't like addressed the streaming community in probably like 2.5 hours, but thank you for stopping by. I appreciate it. We're trying to figure out some bugs in my NES emulator. Those darn bugs. Things are going relatively well overall, but we are having some challenges, as you can see. Okay, so C7E1, C7E3, and then when we do RTI, we end up at C7E3. Hooray! So that worked great. And I think our status register is similar. NMI. Yep. P36. It's 26, which doesn't seem totally correct, but pretty close. And if you pull FD, FE, FF, the NMI FC, FD, FE, yep. Okay, that seems correct. So what's happening now? Why are you exploding on me? Okay. Well, the PC jumped to 10. That doesn't seem right somehow. And then we hit an invalid instruction. How does the PC end up at 10? Decoded operation 10, decoded operation 60. That sounds like a return from subroutine, right? Yep. So we're still popping stuff wrong. That's cool. Something's wrong with JSR, maybe? Hi, kitty. So much cats. RTS. Push PCH, push PCL. Pull PCL, pull PCH. Seems like that ought to be more or less correct. Let me 20 is the JSR instruction. Okay, so operation 20, we push, SP was FF, we push to FEFD, and then when we pulled it, that was correct. Okay, so we're returning from a subroutine we never jumped to, as far as I can tell. Because if we start at the bottom, now we hear. So that's 60, and then 20. Right, so we return twice, because we jump and then we return right here. But then at some point we're returning again without ever having JSR'd. Curious. Also, pulling from the very top of the stack is a bad sign as well. Not very surprising. Let's look at some of these previous opcodes. D088-8D. Branch not equal. Store accumulator. Decrement Y register. branch if not equal. We decrement y to 0. And then you're supposed to jump if the 0 flag is clear, which it's not, or shouldn't be, because y is 0. So you do jump, or you don't jump, rather. 9. Your 2 bytes. Right, 9A, and then B, and you get 60. That's weird. I need to take a break for a minute, get some more water, take a leak, etc. I'll be right back. Okay. Oh, that's... Why is everything black? Oh, there it goes. Okay. All right. I admittedly don't really know where to go from here. This appears to be some kind of loop. And then at the end of the loop, everything dies. I don't know what it would be waiting on. I don't even know if this loop is like where it's actually supposed to be. Just a little confused here. All right, so we have D0, 88, 8D over and over and over again. D0 is branch not equal. 88 is decrement Y. And 8D is store accumulator absolute, which has absolutely nothing to do with Y. And it doesn't automatically increment. So Doesn't seem like that would be a sensible thing to do. Try to get one-to-one nest tests. There's stuff after the no ops. I mean, there is stuff after the no ops, but the so there is stuff after the no ops, but then all the stuff that's after the no ops is unimplemented opcodes. Right? Multi-byte no ops, LAX. It's all just the unimplemented stuff. So it seems to me like it ought to be okay. Yeah. I mean, I'm guessing the problem has to still be with the NMI stuff, right? Because I'm not looking at the right thing. It would seem to make sense to me that the issue is still NMIs because NMIs are untested by NES tests. Maybe there's another test ROM that I could look at. That's an idea. Don't really love that idea, but it's a possibility. Don't really see one for NMIs. Try Balloon Fight. Could do that. Oh, I guess Blarg has a NMI thread, or an NMI one. Do I have IRQs enabled? Implemented. Well, no, I don't. I thought that there weren't any. Unless you were on a particular mapper. I could be wrong about that, though. NMI input is connected to an edge detector. From being high one cycle to being low during the next. I inverted that logic, but it should be correct anyway. Could be right. I just thought about NMI disabling IRQ. Yeah, I don't have any of those hooked up. Oh, hey. I didn't think about this at all. The NMIs are supposed to happen like between instructions, right? You're not supposed to interrupt in the middle. Yeah, I'm not doing that. I wonder if that matters. That would be a good example of what am I trying to say? You think it happens between micro ops? I know it will currently. Like the way I have it implemented, it will do that. Yeah, this is not super helpful. All right. So let's fix that, huh? This is the CPU. Get rid of this. Fetch and decode. So that was saying when it gets checked. I probably don't need to care at that level of detail. Where'd that go? Here we go. Interrupts are pulled during the last cycle of instruction. This is true only when talking about the output from the edge and level detectors. It's really the interrupts at the end of the second to last cycle that matters. Well, how am I supposed to know what the second to last cycle is? Ugh. This is very annoying. Whatever, I'm just going to move it to fetch and decode and see if that helps. Self.nmi. Gotta add this. And then gotta go ahead and grab this junk. Move it into the fetch and decode operation. I guess it should happen first before you actually do anything. And then you should return. And then what you need is if self.nmi and not self.nmi last. That's what we would do there. See if that helps. Probably not. Oh hey, lots of stuff is wrong because it's self instead of CPU. S self CPU G go. Is it just me, or does that seem like it fixed a bunch of problems? That's almost annoying. Yeah. Cool, I guess. That's good. Now what do I do with my life? I guess I delete a bunch of junk, first of all. Yeah, I didn't think that was going to work. Hello, cat. Ooh, tail. Hey, buddy. He's a big goof. I hope he didn't just step on the keyboard. Okay. And then, are we printing anything in the PPU? I don't think so. Okay, so that's just running. Cargo run, dash dash release. Except it's still going to go incredibly slowly. I should have put this back in, actually. right? Because it's still going to incredibly crawl. And I still don't really know why. So that would be the next thing, is to figure out why this is so bananas slow. And then the thing after that would be to figure out why it draws stripy lines. Because it should only be drawing one scan line, but instead it's drawing like every scan line very slowly. It's very weird. I don't know what the hell this is. I'm trying to see a way that this could be a scan line, and it's just not making a lot of sense to me. Are the lines red/pink? Yeah. Which is like kind of correct, except that it's all smeared out and weird. Doesn't make sense. But let's try to figure out why it's running so slow. What am I doing every frame? Basically just this myapp.showTextures thing. Oh, that makes it worse. Or better. I don't know. No, not better. It's just blue instead of red. Okay. So I think I'm doing something wrong here. Let me pull up my reference, which is Nick's code that he sent me. Doodly-doo. Alright, so here's the main loop. Am I recreating the whole thing every frame? Am I supposed to be recreating the whole thing every frame? I'm very confused. I don't understand InGUI at all. Or why I might be... Let texture equal render textures get my texture unwrap. Let raw. Your client format's UI8, but who cares? Texture.write. UI.image. This looks the same to me, except that you're doing cow owned instead of cow borrowed. I wonder if that will work. Probably not. Yeah, I didn't think so. I have to do into here, I guess. Hey, buddy. Nope, same problem. Oops. Gosh, hi, bud. Yes, you're cute. Very annoying. Alright. Well, that didn't help. I wonder if it's the problem is that I'm newing up this window every single time. It doesn't seem right. UI.window. Where do you set this? You never do. Interesting. It's not in here. Probably somewhere else. Nope, apparently not. Where's Nick when you need him, huh? Nope, not better. Same problem. What the heck? Is it faster with text only? Yes. Oh, you mean if I don't do this part? Good question. One must imagine, yes. And yet one would be wrong. Good call, Lila. So... what then? What is happening every main loop that shouldn't be? Am I like copying something every frame or? Don't think so. Pass the CPU in here. I call run UI with it. What does run UI even do? Oh, run UI is just the function that gets passed in, which is just my app.showTextures. I wonder if that's the thing? I don't even know what that is. Nope. Just comment out stuff in the main loop, yeah. Well, what happens if we just don't run our CPU at all? Oh, well, it doesn't print the scan line, obviously. This isn't going to help. Because it's still going to happen very quickly, even though it's very slow compared to how fast it should be. Yeah, that's not helpful. Okay, so we still need to run our CPU. What if we just don't have a UI at all? And all we're doing is running our CPU. Nope, still slow, okay? What if we just don't do any of this junk at all? Okay, well that's faster if you just don't do anything ever. I guess that makes sense, that it would be faster. Okay, and now it's slow again. It's not an event handler. I thought so too. Oh, now I can't close it because I turned off the event handler. It's not just the creation of the window, so that's good, I guess. Bring all this other junk back in. Oh yeah, okay, fine, whatever. That's pretty fast. Well, that doesn't work because I don't destroy it. And now it's very slow. But I'm not doing anything. There's no window. Like, what is your major malfunction, friendo? Yeah, the drawing itself. I don't understand. I wonder if I could just get rid of all of this junk and leave only the target stuff. Oh, it's expecting a window to actually run. And it doesn't have a UI. Which is right here. So that probably didn't do much. Nope. Yeah, okay. So is display.draw in this support thing? Doesn't look like it. What is display? Comes in on init, builder, context, events loop. That's interesting. I wonder if that's wrong. Where's Nick when you need him, huh? How often are you trying to draw the frame? I don't know how to answer that. I guess as quickly as possible. Am I supposed to be waiting for like a paint event or something? I don't think Nick does anything like that. No, he doesn't. I mean, not saying that he's necessarily doing things 100% correctly. All right, let's just go and I downloaded the examples for a reason. Let's just look at them, huh? Okay, well, that's not super helpful. This doesn't look anything like the other thing I'm looking at. Oh, here's the main loop. Yeah, this looks like it's just running as fast as possible too, doesn't it? See examples. dash dash example. I know in SDL2 it would kill my video if I drew as much as possible. Yeah, I mean, that's believable. I don't know how to make it stop. I feel like I should probably... Am I trying to redraw every CPU cycle? Yeah. Currently. That is what is happening, yes. Maybe I should not be doing that. Almost certainly I should not be doing that. Redraw at the same time NMI would happen. Yeah, okay. Easiest way to do that is just do while not self.nmi and not self.nmi last. And we'll just pop out of this every time. Basically, you try to run the game at 4 million FPS. I mean, yeah. Why wouldn't I? You're right, that's pretty dumb. Okay. Oh, I probably still have all that crap commented out, huh? Dope. 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 Got to do this bit. And of course, we only get one frame now because we don't modify NMI outside the thing, and so this happens. So I guess what we need to do is do self.nmi last equals self.nmi here. Do it when NMI would happen, not if it happens. Yeah, okay, that's also true. I don't really have a good setup for that right now, though, so I'm just going to let it do the thing. Okay, so it's at least trying its little best to run. It's not displaying anything at all, which is interesting. Maybe I still have some stuff commented out. But at least it's trying. Oh, I do still have some stuff commented out. All the drawing bits. Sorry, cat, didn't mean to sprinkle water on your head. Hey, look, a red square. That's progress of a sort. It does look way better speed-wise. You're also right that it should be drawn anytime NMI would happen, not just if it does. So I have to think about how that works. I guess I could just return both bits of state from this guy here, and then break out of the loop based on the NMI occurred, not based on this thing. NMI enabled. Compare your name table to mismanaged to see if it's the drawing or the populating. Yeah, I could do that. I'm probably gonna go to bed though, because it is getting on 10 o'clock, and we managed to draw a red square, and that's progress. I'm gonna be streaming a lot tomorrow, so I'll be on probably at a much more reasonable hour for our European friends. But yeah, I'm gonna probably call it for now. Thanks everyone for coming by. Solarak, Lila, Diana. I know there were some other pieces. Diop. Yeah, thanks for coming by. I appreciate it, everybody. Hopefully I'll see you tomorrow. We're making progress. It's gonna be real tight to try to make the Super Mario Bros. 3 happen tomorrow, but regardless, I'm enjoying myself. So thank you again for stopping by, and I'll see you tomorrow.